God, that might be fun.
That's sponsored by Oticon. We've got two talks today. The first talk is by Ronan McGariggle, who's a PhD student with Kevin Monroe, Andrew Stewart, and myself. And Ronan's going to be talking about how to measure listening effort in people with hearing impairment, because we think listening effort is not something that is ordinarily assessed in audiology clinics, but it might actually be quite an important dimension of hearing disability that would be useful to assess in order to assess benefits from hearing interventions and devices and things like that. And Ronan's been using pupillometry measures to try and tap into this measure of listening effort, and he's going to be telling us about that research now. Thanks, Ronan.
Yeah. Okay, thanks, Piers. Okay, yeah, so like Piers said, I'm going to talk about an objective measure of listening effort and fatigue that we're currently investigating, which is pupillometry, and this is just us in the lab. That's me in the background trying really hard to look like an academic, feeling miserably. Okay, so this is a diagram I like to kind of use to help describe what it is I'm interested in. So obviously, and it kind of nicely shows how the cognitive system and the auditory periphery interact. So we obviously our acoustic signals transduced into neural information, and then we select this information with attention and effort, and then this is comprehended and then finally stored in memory. But the bit of this chain that I'm interested in is the listening part. So selecting information with attention and effort. So how do we measure this effort? And what kind of effect does having a hearing impairment have on this effort? Okay, so we're probably all quite intuitively familiar with the concepts of listening effort and fatigue, and they may well be things that we experience ourselves. But just to kind of help guide our interpretation of the literature, we did a review paper recently which kind of helps to define these terms. So listening effort refers to the mental exertion required to attend to and understand an auditory message. Listening related fatigue refers to the extreme tiredness resulting from effortful listening. So we assume that these two concepts are related, but there's actually surprisingly little empirical evidence for this link in the literature. Okay, so why do we care? So why is listening effort and fatigue important in the first place? Why are we trying to capture this? So the most important reason, I think, is that there are frequent anecdotal reports of fatigue and stress from hearing impaired individuals. So just to give you an example, so this is from a profoundly deaf adult. This is a quote from a recent review paper. So I went to a great conference today. It was riveting, and I was hooked on pretty much every word. And then I got home and collapsed on the sofa. I'm not just tired, I'm shattered. I've had to turn off my ears to rest in silence, and my eyes are burning. When I was younger, I was a little embarrassed to be so tired all the time. I would force myself to go out and be busy. All I wanted to do was crawl under the sofa and nap. So that kind of gives you an idea of the sort of fatiguing aspect of aided hearing. So another reason we're interested in listening effort and characterizing listening effort is that the mental effort required to listen for individuals with hearing loss actually detracts from other really important cognitive skills like memory and comprehension. And once again, just to give you a real-life quote, this is from a pediatric audiologist with bilateral hearing loss. I can attest to the fatigue caused by prolonged intensive listening and noise through hearing aids. It seemed like the listening efforts were diverting some of my cognitive resources. So much effort was being devoted to getting the signal that I sometimes missed part of the message. So this is comes from this idea that we have this kind of finite pool of cognitive resources to draw from at any given time. And it's especially important when we really think about children in an educational setting. So we all know that the classrooms are extremely noisy environments. So this kind of thing could really compromise a child's learning and sort of speech understanding. And finally, from a clinical perspective, a reliable, objective measure of listening effort and or fatigue could inform counselling sessions by being able to identify those stress-inducing situations, could inform intervention strategies. So it could be used as another outcome measure of hearing aid benefit. And it could also shed light on cases of uncertainty about the need for intervention. So cases where somebody comes in with a sort of close to normal hearing thresholds, but talks about the difficulty in background noise. Okay, so the potential objective measure of effort and fatigue that we're interested in is pupillometry. So pupil dilation reflects listening effort, and this has been found in hearing research. So larger task-evoked pupil sizes are found in more challenging listening conditions, so compared to easier listening conditions. And then pupil constriction has been found to reflect fatigue. So smaller resting pupil sizes have been found in more subjectively fatigued individuals. So I should point out that this second finding was from eye research. So it hasn't. It's an uncharted territory in terms of hearing research. I should also point out as well that these are very exaggerated versions of what actually happens. I think you would have cause for concern if your pupils dilated that much from listening and noise. But yeah, so I mean, and due to cognitive load due to listening and noise, your pupils shouldn't dilate any more than sort of 0.5 millimeters. So these are exaggerated versions, but hope they get the message across. Okay, so these are our research questions, and what are we interested in investigating? Firstly, can we replicate the pupil response effort effect using our own stimuli and equipment? So using the same kind of listening task as previous studies that have found listening effort, can we replicate this effect, basically? So we tested 24 participants, and yeah, we found this effect. So we've got three conditions here. We've got easy, hard, and passive. Easy was plus 15 dB signal to noise ratio, and the hard condition was minus 8 dB signal to noise ratio. Quite a significant, a big difference there. And then the passive condition was another condition that we introduced, in which the participant wasn't actually required to repeat back the speech. So I should say that participants were required to listen to speech in these different signal to noise ratios and repeat back what they heard. So in the passive condition, they weren't required to attend to the speech in any way. There was no task involved. So, but as you can see, there's a clear difference in pupil response in the hard versus the easy and the passive conditions. And I should also mention that we used, as a baseline, minus 1 second, so 1 second pre-speech onset, which was just noise alone. So we use that as our baseline, and the pupil response is just the change in pupil size relative to that baseline. So can we replicate the effort effect? Yes, it seems we can, using our own stimuli and equipment. So on to our second research. Can this effect be detected in more sort of naturalistic speech processing conditions? So obviously in real life we don't really repeat back sentences at each other, or else we wouldn't get very far with communication. So we just wanted to see what the pupil response was to more sort of extended speech extracts. So what happens there? So what we did was we developed our own listening task called the speech picture verification task, and this is what it involved. So participants saw a fixation cross in the middle of the screen. After 2 seconds, they started to hear noise, multi-talker babble, background noise. And then 1 second later, the speech began. And speech passages were between 13 and 18 seconds long. And once the speech passage and noise had finished, the participants were presented with an image, so shown the pigeon here. And the task was basically, the participants responded yes or no as to whether or not the image that was presented was mentioned at all in the previous passage that they just heard. This target object, so in this case the pigeon, may have been mentioned at the start, at the end, or the middle of the passage. So they couldn't just listen to a particular part of the passage alone. Okay, so that was the task. And once again, the pupil response was calculated as the relative change from baseline, which was our noise alone presentation. Okay, and this is what we found. So this is 12. We had 12 seconds of data, basically. The shortest speech passage was 12 seconds. So what this is showing is the pupil response to speech processing alone. So there's no kind of anticipatory behavioral response artifacts towards the end. That's just speech processing. In order to analyze the data, we divided the data into 4 time bins. So the canonical stimulus-driven task of pupil response tends to occur after a few seconds of speech onset. So we were interested in that first sort of time window, and that was kind of like our listening effort window. And what we found was we did find a significant difference in that time window, and that was the only significant difference in this data, or in this study. Okay, so we were able to replicate the listening effort effect in more naturalistic speech processing conditions. Okay, so the third research question then was, is pupillometry also sensitive to differences in listening-related fatigue? So obviously, so our task we used was a randomized design. So hard and easy trials were interspersed. So it was quite difficult to tease apart any kind of possible fatigue effects that were due to one condition or the other. So it wasn't really set up to really investigate this question. However, I mean, upon visual inspection of the data, it does seem like the patterns converge towards the end of speech processing, and they eventually actually overlap if you look at the final time window. And we tentatively suggest that this may reflect some form of listening-related fatigue. We don't know for sure yet, but that's just a possibility. So that research question really is for another study. And one way of possibly investigating that the fatigue response is maybe to use a block design. So this is what we were considering for our next study, so that we can look at the effects of each listening condition separately on resting pupil size after a sort of a prolonged period of exposure to either listening condition. So some other research questions that we're interested in for future research is whether or not pupillometry is sensitive to changes in listening effort and fatigue in the child and or clinical population, and also what are the cognitive predictors of listening effort and listening-related fatigue. Okay, so our conclusions based on the data presented here. Pupillometry is sensitive to differences in listening effort in a naturalistic listening task. Pupillometry may also reflect listening-related fatigue, but like I say, this requires more research really to clarify this possible link. And this could help to provide an important empirical link between listening effort and fatigue. So to use a sort of an analogy from a Roald Dahl, famous Roald Dahl story, if we think of listening effort and objective measures of listening effort as Wonka bars, and then we can think of listening-related fatigue and finding an objective measure of fatigue as the kind of the golden ticket. So we know that the two are related, and we know that you have to buy a Wonka bar in order to get the golden ticket. But just because you buy a Wonka bar doesn't necessarily mean you'll end up with that golden ticket. So we're kind of interested in clarifying that link. So on cue, Wonka bar. And so I'd like to thank the Castine Foundation for providing the funding for this research, and of course my supervisors, Kevin and Piers, and Andrew Stewart. And thank you all for listening
Got time for a couple of questions. Chris?
So, Ronan, you say that pupillometry can detect the effects of listening effort, but you're not actually measuring, you don't have an independent measure of listening effort. You're assuming, right, that the harder task has more effort. So how do you make that kind of link? Is that from other data, or are you just assuming that if it's a harder task, it has to be more effortful?
Yeah, it's a good point. I mean, a lot of listening effort research, and there's a lot of different measures that you can use to actually measure effort. There's subjective measures, behavioral measures. I didn't really get a chance to discuss them here, and often the problem is that they often don't correlate. That's obviously a big problem, because if it's not, if it's not reported effort, then what is it that we're measuring? I did actually record subjective reports from these studies, so people rated how much effort they kind of they felt they exerted in each condition, and and they showed a difference. So they found the hard conditions subjectively more effortful as well.
Okay.
I guess that's the answer.
Kai?
Yeah. Maybe I wasn't listening effortfully enough, but I I'm a little confused. So the assumption is that listening effort causes fatigue and not stress. Is that right? Because if you're using pupil measures, then actually these two, are opposite to each other. So would you like to comment on that? Because I would imagine that some people get fatigued and some people get very stressed out. Then how do you?
But not everyone. You mean? Is that what you're sort of?
No, I don't know. I'm sort of I wasn't clear how you conceptualize it.
Yeah. Okay. So again, short talk. I didn't have much of a chance to get it. Well, so pupil measures of listening effort reflect activity in the brainstem. So in the locus ceruleus. So that's kind of general, the attentional network we call it. The fatigue response, which is the smaller pupil sizes, is like is sort of parasympathetic dominance. So it's whenever we were trying to conserve energy. So there's slightly different mechanisms in place, so like different physiological mechanisms. Whether we can actually precisely and sensitively measure both of these things in the same experiment, we haven't yet been able to prove. But we think that finding this empirical link is really important between the two. As for the stress, I mean, that isn't something that we're looking at specifically, but again, I mean, we assume that people, if they're fatigued, then they're going to be stressed. Possibly. I don't know. I mean, again, it's something that we haven't really investigated, so I can't really comment conclusively on
In
that.
some ways, it would be maybe easier not to actually call these reactions what they are, that it is a sympathetic response and parasympathetic response. I feel almost this fatigue, calling it a fatigue is almost like a name that we attach to that. I mean, I'm not so sure about this. I mean, I think it's very, very interesting research, but I'm not so convinced about this labeling.
So it's the fatigue that you're not so convinced yet, or is it the effort bit as well you're referring to?
No, I think when you're actually looking at pupil size changes, then all you can say for sure is that you are looking at the changes in sympathetic and parasympathetic system, for sure.
Yeah, I mean that is true, but that's not the only thing that pupil changes reflects, and that pupil size changes.
Yeah, no, absolutely.
But
I think the point's quite important.
Yeah.
That we're interested in fatigue, and what is it we're actually getting from these measures? Is it a direct measure of fatigue? Is it an indirect measure, or what is it it's showing us?
Yeah. Certainly the fatigue response is
and stress is
a
relevant.
parasympathetic, is an autonomic activity response. So it cannot be sort of teased apart from that. It is what it is.
Okay, thanks very much, Ronan.
Mm-hmm.